Hi gents, welcome back. We're going to do a coordinate geometry of the circle question. We're coming out towards the end of coordinate geometry of the circle. Just as regards the exams, I prefer to spend a bit more time just going over some revision stuff. Okay, I've taken exercise 8.5 and I've taken question 5. It asks us to find the equation of the circle that contains these 3 points. Okay, now there are 2 ways to do it, and I'm going to show both, and I really do recommend that you do both of these things here. It's a bit of a hike for sure, but it's worthwhile being able to do it. So if we start off and say that the general equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Unfortunately for this one, we can't hide away. We can't say, the x minus h in a bracket squared one. That one is not going to work for us in this case quite so easily as what this one will. It will actually work, but this one's just a little bit easier to do. So here's what we would do. Here's the first way. What does 4, 1 mean? Well, if it's on the circle, it means that you can sub it in for x, the x value, and sub in 1 for the y value, and you will get a truthful equation. Okay, and if you did do that, and actually I'll just start it, we'd get 4 squared plus 1 squared plus 2g times 4 plus 2f times 1 plus c equals 0. You'll find that you then have an equation that has only g's, f's, and c's in it. And if you then go and place in the other point, you'll also have a second equation with g's, f's, and c's. And finally, if you put in 2, 3, you have a third equation with g's, f's, and c's, and therefore you'll have a simultaneous equation with 3 variables. So it's actually very like an algebra question. In fact, it is just an algebra question in disguise. And that's not the first time that we've had that with the circle. Okay, so we can say from that first one that we get 8g plus 2f plus c is equal to, and we'll subtract 17 from both sides. There's our very first equation. We'll keep doing that. We'll place in minus 2 now. Minus 2 squared plus 1 squared. That's our y value, our x value, and our y value. We're now using this in here. Plus 2g times minus 2, that's our x value, plus 2f times 1 plus c equals 0. So we get 4 plus 1 minus 4g's plus 2f's plus c equals 0. So we get minus 4g plus 2f plus c is equal to minus 5. That's our second equation, and we'll do our third one now. It's x squared, 2 squared, plus y squared, plus 2g times x, plus 2f times y, plus c equals 0. So we get 4 plus 9 plus 4g's plus 6f's plus c is equal to 0. So we have 4g plus 6f plus c is equal to, and this time we will subtract 13 from both sides. That's our third equation. Okay, it's simultaneous equations. It's just simultaneous equations. You will notice that the c's are, absolutely primed to set up. And I also noticed that with 1 and 2, it's also primed for f's as well, which is by luck. That won't always be the case, but be very easy to eliminate the c's from everything. So we'll leave that first equation, minus 17, the first one, and we'll take the second one and we'll multiply by minus 1. We get 4g minus 2f minus c is equal to 5. So we end up getting 12g's. No f's or c's, which is excellent, is equal to minus 12. So we get that g is equal to minus 1. Okay, so far so good. With that piece of knowledge, then you can just sub it in to any of the 2 and just go from there. So we'll do 2 and 3 there. If g is minus 1, if g is minus 1, we have minus 4 times minus 1 plus 2f plus c is equal to minus 5. So we get 4 plus 2f plus c is equal to minus 5. We get 2f plus c is equal to minus 9. Okay, we're also subbing in g equals minus 1 over here. So what we'll end up with is with 4 times minus 1 plus 6f plus c equals minus 13. So minus 4 plus 6f plus c equals minus 13. 6f plus c is equal to, and that's going to be minus 9. Okay, so here are our new equations all set to go. We'll say 6f plus c equals minus 9, and we'll take that other equation multiplied by minus 1. Minus 2f minus c is equal to 9. And when we add those together, we get 4f's, no c's, which is perfect, is equal to 0. So 4 times the number is 0. That number has to be 0 itself. And we can now sub that back in. Suppose we'll throw it into this one here. It's as good as any. 2f's, so 2 times 0 plus c is equal to minus 9. So we just get c is minus 9. So there we have it. We've got g is minus 1, f is 0, c is minus 9. And what we actually asked the equation, so x squared plus y squared plus 2gx plus 2fy plus c equals 0. That's going to be x squared plus y squared. Now 2gx. So g is that, so 2g is minus 2. F is that, so 2f's are 0. So we can just sub those things in. So 2g is minus 2x's plus 2f, that's 0 y's, plus c. C is a minus number. There we go. So it should be x squared plus y squared minus 2x minus 9 equals 0. And I'm just going to double check that. You could take each point and sub it in, because obviously you won't have a book to look, well, you will for this exam I suppose, but you in general for the Leaving Cert won't have a book to look into. So there's 8.5, question 5, x squared plus y squared minus 2x minus 9 equals 0. Excellent, good, we are all good to go. Okay, so it's just an algebra question really. I'm going to show you the second way to do it. Okay, it's going to look maybe a little ugly. Let's have a look at it. Okay, we were given 3 points, recall. In fact, I'll just give myself a little bit more space. Okay, the 3 points were, and these, does not have to be nice where you put them. 4, 1. We were told that another point was minus 2, 1. So you can see that, I don't care where I'm writing the point in, it's absolutely fine. I'm trying to say you'll get the point of it, but without using that for obvious reasons. Yeah, well, look, let's just show you how to do it. Okay, it doesn't matter where you orientate the points on the circle. It's only an illustrative thing. Okay, it's only to illustrate what it is that's happening. Okay, here's something that you will probably have forgotten from the junior cert. If you take a chord across here, I might do this actually just in a different color, just so we can see it. If we take a chord there, okay, wherever the center of the circle is, let's say it's approximately there, this will be the perpendicular bisector of it. Okay, and if you take another chord, we could have chosen the other one there, by the way. And if you cut this line in half, okay, well, no, it's about there. And if you draw the line which is also a perpendicular bisector of it, it is going to land at the center. Okay, it is going to land at the center. Now think of it. If you know the center point, what you can then do with the center point is you can get the radius, and if you know the radius and the center, you know the answer. So there's a lot to do there. There's a lot to do there. This is what I'm going to do first of all. I'm going to get the equation of this line here. I'm going to get the equation of that thing there. So to get the equation of that line, we first of all should get what is the slope of this line here. Okay, now -2, 1, and 4, 1. I'm just getting what is the slope of that line there. You have a formula, y2 minus y1 over x2 minus x1, but I also want you to think of it as rise over run. This is how I just started to do it. X, y, x, y, that sort of thing. So it's rise over run. So how much have you gone up? Well, what was the height? The height was 1 and is now 1. So your rise is 0. Okay, what's your run? How much have you moved over? Well, we went from -2 over to 4. We moved over 6. And actually 0 divided by 6 is just 0. So it has a slope of 0. Now, in this case, they've made things a little bit tricky for us, because what's actually happening is if something has a slope of 0, it's just going straight. Sorry, it's not going straight up. It's just going. I was getting the answer. It is just going straight across. I mean, if you think about it, makes sense here. What you would have here is you would have -2, 1. Boy, I've picked some example here, and you've got 4, 1. Okay, they are in perfect line with each other. But what I'm trying to get here is I'm trying to get the equation of this line here. Now the problem is, normally we would just say, oh yeah, it's the perpendicular, flip it upside down. Well, the problem with flipping it upside down is that you get 6 divided by 0. It does not exist. So you actually can't, this is a very unusual case where you can't write that. Okay, but we can get the equation of this line here. Okay, what would the midpoint be? If you've got -2, 1 and you've got 4, 1, the middle point, well, it's just the average of -2 and 4. To be honest with you, it's just the average of the two things. So we could add them together and divide by 2, and what we get, is we would get, when we add them together, we get 2 divided by 1, we get 1, 0. Okay, and that makes sense. You've moved over 3 and you're moving over another 3. Okay, that's 1, 0. But if you think about the, well, in fact, it's not 1, 0, beg your pardon, it's 1, 1. Because this one had a height of 1. This isn't the x-axis, by the way. The x-axis might be down there. So this is 1, 1, but I'm just saying that this is in a straight line. So the next one would be, for instance, what would this one be? This would be, it's probably better if I actually draw in the real axis. Okay, so if you imagine that this is our x-axis and this is our y-axis, something like that. Okay, this point here would be, would be 1, 2. Next point would be 1, 3, etc. So from the junior cert, hopefully you know that this line here, and by the way, this line here is equivalent to this line here. That line there is simply where the x value is always 1. It's x equals 1. This one here is the line where y is equal to 1. Just to say, okay, no, sorry, not that line, but the one going across here. Okay, this is our x-axis. This is our y-axis. Okay, so hopefully you knew that one already from the junior cert. If you've the x and y-axis, might be better to use a different color here. You know, if you have this line here, and let's say this goes through the point 3, 0. Okay, this is going to be 3, 1, etc. This is everywhere where the x value will be 3. Whereas if we take another line going across here, ooh, what the heck? Okay, so if we say that this is, wow, 0, oh god, that's, yeah, that makes me ill. 0 minus 2. Okay, what's, you know, this point is going to be -1, -2, -2, -2, etc. So this is everywhere where the height, where the y value is -2. That's what the equation of that one would be. Okay, that's basically all that we're saying here. So this is quite an unusual example where we don't have 2 points where they're at angles to each other. This is literally just straight across. Okay, this one is straight across. So actually, what we were trying to get the whole time was we were trying to get that one there. We were trying to get the equation of this line here, and I told you that we got it. So let's just remember this equation going across here. What's staying the same for that one? It's y equals 1. And for this one here, it was x is equal to 1. We got the midpoint of it. So we now know what the equation of that line is. Okay, let's see a different one. Okay, let's see a different one. This one, I can tell immediately this one is much more typical of what you're dealing with. Okay, so we're going to get the slope of this line here. It's going from -2, 1 to 2, 3. Rise over 1. Rise over 1. Okay, how much has it risen? It's gone from a height, that's the y value, of 1 to 3, risen by 2. How much has it moved over? It went from -2 to 2, it went to 4. So that slope is equal to 1/2. That's what that is. But we're trying to get the slope of this perpendicular line here. So the perpendicular slope will equal to -2. Because you remember, it has to be that they multiply together to give -1, or another way to think about it is that you take the previous slope, turn it upside down, and change the overall sign, -2 over 1, which is 2. Okay, we now have the slope of this line, and we just need a point on it in order to be able to get the equation. So the point is the midpoint. Our point that we could get is the midpoint, -2, 1, and 2, 3. And again, you've got a formula, but you can just say, what's the average of the x's? So if I add the two x's together and divide by 2, I'm going to get 0. And with the y's, if I add them together, I get 4, and divided by 2, my average is 2. So I now have a point, 0, 2, and I have a slope. So I can now get the equation of this line here. Okay, that's a really important line to have. So it's y minus y1 equals m times x minus x1. Bet you're preferring the previous example around about now. So it's y minus 2 is equal to m, which is -2 times x minus x1, so that's -0. So the equation we get is y minus 2 is equal to -2x, or put another way, it's 2x plus y minus 2 equals 0. We now have two equations. We have this really unusual one here, which is x equals 1. And we also have the equation, so that was our first one, this is our second one. Now, what would normally happen, and in fact, it would happen if we did it with this one. With this one here, if you get the slope of that line, and then the slope of the perpendicular, and then you get the midpoint, you'll have this slope, you'll have that point, you'll be able to get an equation of a line, and just do simultaneous equations to find this center point here. As it is, we can do simultaneous equations with these ones here. It just so happens that we have a really easy one because we're already told that x is 1. So if you actually just sub it in, you'll end up with 2 plus y minus 2 equals 0. And you'll actually end up with y is equal to 0. So actually, we know what the center is. The center is 1, 0. Okay. We'll also be able to get what is the what's the radius, because if you have the center 1, 0 and you want to get the radius, we'll say 4, 1. We'll just get the distance between it. Let's just use the formula. We haven't used it in a while. x1 y1 x2 y2. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's equal to 4 minus 1 squared plus y2, which is 1, minus y1 squared. Okay. So we end up getting, it's the square root of 3 squared plus 1 squared. So that is root 10. That's the distance, which is the radius. Okay, we've got the center. Center was 1, 0. That was what we were figuring out. 1, 0, and we've got the radius, which is root 10. And remember, the other one, x minus h squared plus y minus k squared is equal to r squared. That's h, sorry, and that's k. That's what the center is. So we get x minus 1 squared, plus y minus 0 squared is equal to root 10 squared. Let's just show that that is what we got above. It's x squared minus 2x plus 1. So we get it if we multiply it out. Y minus 0 is just y, so that's just y squared. And root 10 when squared is just 10. And if we tidy that up, we get x squared plus y squared minus 2x. And if we subtract 10 from both sides, we get minus 9 equals 0. That's the equation of the circle. It would have been fine to leave it like that. Well, you might just change root 10 squared to just 10 and maybe y minus 0 squared to y squared. But if you check that answer and compare it to when we did our simultaneous equation, you get the exact same answer. Ooh, okay, I know which one I prefer out of the two of those. This is what I'm going to suggest. I suggest that you do exercise 8.5. You definitely want to practice that one out. Exercise 8.5, and I would suggest that you give question 6 a go. You're not going to have that annoying, well, I suppose in some ways it's annoying. You're not going to have that x equals 1, y equals, you'll just get relatively more normal equations with an x and a y in question 6. Okay, gents, hope that was useful. All the best.